guys, I will be discussing about bisection method. Bisection method is finding method implemented by approximating a root in the midpoint. So we have here an example function which is x cubed minus 2x minus 5, and first you have to assume your lower, which is xl2, and your upper 3. So you have to get your f of xl and f of xu. You can get your f of xl by substituting your value here in our function. So have here 2 cubed minus 2 times 2 minus 5 is equals to 1. So next, you can get your f of xu by substituting also your value of xu in our function. So we have here 3 cubed minus 2, 3. 2 times 3 minus 5 is 16. So if you multiply your f of xl and f of xu, it should be negative or less than to 0. So have here f of xl, which is negative 1, multiplied by 16, which is our f of xu, is equals to negative 16 or is less than to 0. Next, you have to get your midpoint or your xm. So the formula in getting the xm is xl, which is your lower, x plus xu over 2. So you have to substitute your values here so that you can get your xm. So xl plus xu, or 2 plus 3 over 2, is 5 over 2 or 2.5. So next, you have to get your f of xm. So f of xm, you can get your value of f of xm by substituting the value of your xm in our function. So we have here 2.5 cubed minus 2 times 2.5 minus 5 equals 5.625. So in bisection method, there is a condition that if your uh, f of xl multiplied by f of xm is less than 0 or negative, you can set your new your new xu by your xm. So here, f of xl multiplied by f of xm should be less than 0 or negative. So here, negative 1 multiplied by 5.625 is negative 5.625 or is less than to 0. So you can set your xm into your new xu. So we have here new xu is 2.5 and your xl is 2. So like what we do here in our xm, do also here. So you can get your new xm, which is 2 plus 2.5 over 2 is 3.8125. So you have to get also your f of xm again here. So we have by substituting this value in our function. So we have here 3.8125 cubed minus 2 times 3.8125 minus 5 is 42.7903. Then we will do again what we do here so that we can get our new xu. So have here negative 1.42.7903 is equals to negative 42.7903. It is the less than to 0 because it is negative. So you can see we have here our value of our f of xl negative 1. So as long as your f of xm is positive, you can get your new xu by the means of getting the value of x xm. So have here our new xu, which is 3.8125, and our lower is 2. So I have here getting xm again. So 2 plus 3.8125 over 2 is 2.903. Then getting the f of xm again, have here 2.903 cubed minus 2 times 2.903 minus 5 is 13.7957. So again, it is positive, so our xm here will be our new xu. So we will compute again our xm. So we have here 2 plus 13.7957 over 2 is equals to 2.4532 is equals to 2.532. Then getting the f of xm equals 2.4532 cubed minus 2 times 2.4532 minus 5 is 4.8547. Again, it is positive, so we will get the value of our xm so it can be our new xu. So here, getting again the xm, so 2 plus 2.4532 over 2 is 2.2226. So getting again the f of xm, which is 1.5867. So it is positive again, so we have to get our xm, so it, it will become our new xu. So getting again the xm, 2 plus 2.2266 over 2 is 2.1166. So getting again the f of xm, which is 0.2115. So we will get our xm values, which is at first iteration it is 2.5, second iteration is 3.8125, at third iteration it is 2.903, at fourth iteration it is 2.54532, in the fifth iteration we have here 2.2266, and our sixth iteration is 2.116. So we will compute for our error. So here, so computing our error, so first, computing our error, have to get your true value minus approximate value over approximate value, and it is absolute. Then multiply it by 100. So we can say that our true value is our previous value, which is 2.5, minus the approximate value, which is our present value here, so 3.8125 over 3.8125. Absolute multiplied by 100 is equals to 34.43%. So in getting the error, you can say that in getting the error, if you have your value close to your true value, so you will say that if you continue doing your errors. That's all. Thank you.